Alrighty, welcome back, guys. So what we're going to do today is just review how to do stoichiometry, since I know it's been 2 weeks we've been on break, but we're going to continue using stoichiometry for our upcoming labs and the exam that's going to be at the end of the semester. Okay, so the first thing that we want to do for stoichiometry is we want to start by balancing the equation. Okay, so the number one thing that we're going to do is we're going to balance the chemical equation. Even before we read the problem or anything like that, we want to start by balancing. Okay, so to do that, what we're going to do is we're just going to list all of the elements that are in the reaction. And so here we just look at the capital letters. So we have uranium, U, capital F, and then capital Mg. The lowercase letter applies to the capital in front of it. So here we have 3 different elements. And if you notice, you should have the same ones on the right side. So we're just going to make a quick table. And then what we're going to do is we're going to count how many of each we have on both sides of the equation. So if we take a look on the left side, you're going to notice that there's 1 uranium. If there's no number behind it, it means there is only one of them. So we have 1 uranium, 4 fluorine, 1 magnesium. On the right side, we have 1 magnesium, 2 fluorines, and 1 uranium. And so what we want to do is we want to add to the side that has less, okay? So we're going to add to the side with less. So if you notice, uranium and magnesium are balanced, but fluorine is not, F is not. So we want to add to the side that has less. There's less on the right side. So we're going to add some fluorines to the right side. However, you can't just add the elements individually. I can't just do F by itself like that. You have to add the whole molecule, okay? You want to add the whole molecule. So what that means is you're going to add the entire molecule that's originally in this reaction. Okay, you're not adding anything new. You're just going to copy down the exact same molecule. So you have MgF2. So now it changes our number for Mg. Now there are 2 Mgs on the right side, and there are 4 Fs on the right side. Okay, and so our U is balanced, our F is balanced, but our Mg is not balanced. So we just add to the side that has less. The left side has less. And here I can just add Mg by itself because in the reaction, in the equation, I have Mg by itself. Okay, so all we need to do is put the coefficients or numbers in front. I have 2 Mg, so I put a 2 right here. And I have 2 of these. Now I put a 2 in front of it. Okay, and that's our balanced equation. Now, if you guys notice, I didn't change anything about the equation. All I did was put numbers in the front. Okay, and so this is what our balanced equation looks like. Again, you don't add anything or change the equation. All you do is put numbers in the front to show that's how many you need. Okay, so that's our first part. The second part is you want to find the molar mass of the important chemicals. Okay, you want to find the molar mass of the important chemicals. And here we're going to have to read the problem. So here it says, how many grams of MgF2 can be produced in the reaction below between 17.35 grams of UF4 and excess Mg. Now, if you ever see the word excess, that means you have so much you don't need to worry about it. An excess of it, you have so much. So what that means is our Mg is not going to be important in this problem. Now, we also know that when we do dimensional analysis or stoichiometry, it's important for us to know what the given number is, our starting number, and what we want to end up with. So if you take a look at this problem, the only number that we have is 17.35 grams of UF4. So we have 17.35 grams of UF4. Okay, what that means is this is our starting number. So that means UF4 is going to be important, which means I need to find the molar mass of UF4. Okay, now the other chemical that's important is what you want to end up with. The question is asking how many grams of MgF2 we produce. And that means MgF2, this is also going to be important, which means I need to find the molar mass of UF4 and MgF2. Now, it doesn't say anything about U, so we don't need to worry about U as well. These are the 2 important chemicals, and those are the ones that we're going to find the molar mass of. And so what that means is we want to go to the periodic table, and then we're going to pull up, one sec, I'm going to pull up my periodic table. Hello. All right, there it is. So we're going to pull up our periodic table, and what we're going to do is we're just going to find the molar mass of the important chemicals. So here we have, we just said that UF4 is important. So we're going to go to the periodic table and look up U. And so if you look at the very bottom, uranium, U is 238.03. And so I'm going to pull up my calculator. And I'm going to do 238.03. Now, the chemical's formula is UF4. And so that means there's going to be 4 Fs. There's going to be 4 fluorines. Each fluorine is 19. So we just need to add 19 4 times. And so our final answer becomes 314.03. That means that UF4 has a molar mass of 314.03 grams per mole. So 314.03 grams per mole. Okay, and all I did was add up each of the elements. Now, if you are watching this video to review, take a second to pause the video and try to find the molar mass of MgF2. Okay, so pause the video and try to solve that out. All right, so hopefully you were able to find the molar mass of MgF2. Let's see if you guys got the correct answer. So I'm going to go to the periodic table and look up Mg and F. Okay, Mg is 24.3, so 24.3, and it's F2, so we need to add F2 times. That'll give us a molar mass of 62.3. Okay. Now, one thing I do want to mention is when you find the molar mass, you don't care about the coefficient from the balancing. Molar mass only has to do with the formula of the molecule, not the number in the front, okay? All right, so now we have the molar mass, we balanced it, we have the given and our end, and so now we can finally do the stoichiometry. So we're gonna do the dimensional analysis. Okay, you're gonna take your starting number of 17.35 grams, 17.35 grams of UF4. And then hopefully you remember that we always set up 3 fractions. And then on the top of the fractions, we always put gmga. Okay, gmga. G is grams, m is moles, m is moles, and g is grams. So gmga. Okay, this is going to allow us to put in our numbers and our units of measurement more easily. Now, you guys might also remember that the first 2 fractions are about the same chemical. So the first 2 fractions are going to be about UF4, and the last 2 fractions are going to be about the same chemical. Now, we want to end up with grams of MgF2, which means that this last fraction is going to be grams of MgF2, which means that the last 2 fractions are about MgF2. Okay, so we have our setup. All we need to do is plug in the numbers and fill in the bottoms now. Okay, so we start with 17.35 grams of UF4. If I have something on the top of the fraction I want to get rid of, I'm going to put it on the bottom of the fraction. Okay, so grams of UF4. Since I have grams of UF4, I want to put that right here so they can end up canceling out. Now, if you have grams and moles on the same fraction, you are always going to get the numbers from the molar mass. So we're going to look at the molar mass of UF4. The molar mass of UF4 is 314.03, and it's grams per mole. So for molar mass, it's always going to be number 1 next to moles, and whatever you added up from the periodic table is going to go next to grams. So if we do that, the grams of UF4 can cancel out, and then now we can put moles of UF4 on the bottom. Here I have moles and moles on the same fraction, so I'm going to get the numbers from the balanced equation. So whatever numbers are in front of the molecules in the equation is going to be what we put in front of it. So MgF2 has the number 2 in front of it, so I put a 2 in front of moles of MgF2. UF4 has no number in front of it, and if it's no number, it's going to be 1. So we put a 1 there, and the moles can cancel. And then lastly, we're going to put moles of MgF2 on the bottom. Since I have grams and moles on the same fraction again, I'm going to get the numbers from the molar mass. Molar mass of MgF2 is 62.3. So I put that number next to grams, and it's always 1 mole. Now, if this is kind of difficult for you to figure out where you get the numbers from, honestly, it might help just to memorize it. The first fraction has the numbers from the molar mass. The second one is the balance equation, and the third one is the molar mass as well. Okay, so now we can solve out our fraction. Now just remember that the numbers that we have on the top, we are going to multiply, and the numbers that we have on the bottom, we are going to divide. And so we're going to pull up our calculator again. The first number that we have is 17.35. The number on the bottom is 314.03. So I'm going to divide by that. I have a 2 on the top, so I'm going to multiply it by 2. And then I have a 62.3 on the top, so I can multiply by 62.3. And our final answer is going to be 6.884. And then the unit of measurement is going to be grams of MgF2. Okay, so hopefully that was helpful. Now, you do have all the problems on your assignment today are going to be just like this. I believe that the equations are different and the numbers are different, but you're going to follow the same basic steps. I know it can be kind of tricky, and it's been a long time since we've done it. So you only have 4 problems on your assignment today. So hopefully that won't be too bad. I have the answer key up in the front, so if you guys have any questions, make sure you guys check with me, and if you want to double check your answers before turning it in, feel free to do that as well. Okay. All right. Good luck on your assignment, guys.